Hello everyone. In this problem we are given a positive array nums and we have to find the largest possible perimeter of a polygon where we can use the given array as the sides of this polygon. And if we cannot construct a polygon using it, then we can return -1. Let's look at some conditions that is required to form a valid polygon. The first condition is that the polygon must at least contain 3 sides. So all of these are valid polygons. And the second condition is that the maximum side of the polygon must be strictly less than the sum of all the remaining sides. Let's look at the given examples to understand this better. In our third example, we see that the maximum side is 50 and the sum of the remaining two sides is only 10. And since the sum of the remaining sides is not greater than the maximum side, our second condition fails, hence this is not a valid polygon. Please note that we cannot further try to make a smaller polygon because in that case the number of sides will be less than 3 and this is not possible. In our first example, we see that the maximum side 5 is less than the sum of the remaining two sides. Hence this is a valid polygon with the perimeter as 15. In our third example, the maximum side is 50 and the sum of the remaining sides is not greater than 50. So we cannot construct a polygon using the side 50. Hence we'll try to construct a smaller polygon. So from the remaining sides, we can see that 12 is the maximum that we have. And in this case, we see that the sum of the remaining sides is equal to 12. For the second condition to be true, the sum of the remaining sides must be strictly greater. Hence we cannot construct a polygon using 12 as a side. Now we'll try with 5 being the new maximum of the polygon. And in this case, the sum of the remaining sides is greater than 5. So this is a valid polygon. And the perimeter of this polygon will be the sum of all these sides. Let's try to come up with an intuitive solution for this. In the previous example, you can notice that we tried to make a polygon with the maximum value as the largest side. And if this does not work out, then we try to find the second maximum and then try to make it the largest side. And even if this does not work out, then we try to find the next maximum and so on. So maybe you can notice that if we sort this array, then finding the largest side will be easier. Now let's look at the sides in sorted order. First of all, we'll consider 50 to be the largest side and then compare it with the sum of the remaining sides. We can see that this is not a valid polygon. So now we'll consider 12 to be the maximum side and we'll compare it with the remaining sides. The question you might have is that whether we have to find the sum of all the remaining sides again or can we reuse some previously computed values. So every time we are checking for a smaller polygon, we have to find the sum of the remaining sides starting from right to left. We can minimize this computation every time by finding the sum of the whole array and then subtracting the relevant values each time. Our total will be 74 and if we subtract 50 from it, then we'll get the sum of the remaining sides. We see that the sum of the remaining sides is not greater than the largest side, so we'll try with the next maximum. We'll also be keeping track of the sum of the elements from the right, because as we eliminate those larger sides and we try with the next larger side, the sum of the remaining sides will also decrease, and to find that we can subtract from the total the sum of the elements on the right. For example, when we encounter the next element, we'll increase our current sum. And when we subtract this from the total, we'll get a new sum of the remaining sides. Similarly, we'll compute the sum of the remaining sides for the next larger element. In this case, the sum of the remaining is greater than the largest side, so this is a valid polygon. Please note that to find the perimeter, we also have to add the largest side to the sum of the remaining sides. Hence 12 will be your answer. The time complexity of this would be O of n log n, because we have to sort the array, and the space complexity would depend upon the sorting algorithm used by the library and the language, and in the best case it would be constant. Let's implement our solution. The first thing that we'll do is sort our array, and we'll keep a variable to store the sum of the array. To calculate the sum of the right side, we'll keep a variable and initialize it to 0. Since we have to access the largest elements first, we'll write a for loop in reversed order. We'll add the current value to the sum of the elements on the right, and to find the remaining sum, we'll subtract this from our total sum. Now we'll check if the remaining sum is greater than the current largest element. In that case, our perimeter will be the sum of the remaining elements plus our current element. So we'll return this value directly. And if at the end we did not find any valid polygon, in that case we'll return -1. We are now done with our solution. Let's submit it. If this video was helpful, please leave a like and also a feedback. And please remember to subscribe to the channel for more such content, and thanks for watching.